Okay, we're going to work on sample problem 12.3, drawing hydrogen bonds between molecules of a substance. And for this problem, we're indicating just individual molecules, and we're asking the question, can they hydrogen bond to another like molecule if we had, for example, a pure solution of this substance? We'll also consider from time to time hydrogen bonding between two different molecules, but this problem is just set up to look at hydrogen bonding between two of the same molecules. And note that this is different than asking, can this molecule hydrogen bond within itself? We're not asking that question because that rarely happens. Most often, again, when we're considering hydrogen bonding, it's an intermolecular force, so an interaction between two molecules. But again, in this case, we're looking at two of the same molecules. Remember, in order to have hydrogen bonding, you have to have one of three elements within your compound. You have to have a nitrogen, an oxygen, or a fluorine. And when you have those atoms, for them to be a hydrogen bond acceptor, you have to have lone pairs of electrons. So we have to look for that. So even if you have oxygen or nitrogen or fluorine, if they're bonded in a way such that they don't have lone pairs, you won't have hydrogen bonding. That's not tending to be the case with oxygen or fluorine, but with nitrogen that is possible. So we have to have a hydrogen bond acceptor. And then you also have to have a hydrogen bond donor. And the hydrogen bond donor is a hydrogen that's attached to one of these three elements. Okay, so let's look at these three molecules and then we can ask these questions. Let's look at our first molecule here, C2H6. Well, first of all, if we want to have hydrogen bonding, we have to have a nitrogen, oxygen, or fluorine within this molecule. So in this case, we don't have that, so no hydrogen bonding is possible. In our next example here, we can see that there is an oxygen, but it's very important that when we look at this molecule, we ask the question about where molecules where atoms are bonded. So let's go ahead just for this one and draw out a Lewis structure for this, just so we can make sure to see where the atoms are bonded and ask who's capable of being hydrogen bond acceptors or donors. Because remember, to have a hydrogen bond, you have to have somebody who's willing to donate the hydrogen bond, so a hydrogen attached to one of these three atoms, but you also have somebody who's going to be the acceptor in that intermolecular interaction. So in this case, we can see within this molecule, the oxygen could serve as a hydrogen bond acceptor. And we also do have a hydrogen that's attached to an oxygen. So in this case, if we have two of these molecules that are next to one another, one molecule could act as the hydrogen bond donor, and one could serve as the hydrogen bond acceptor. And within this molecule, there's really only one hydrogen that can serve as a hydrogen bond donor. Even though there's four hydrogens that are within this molecule, because these hydrogens are not directly attached to nitrogen, oxygen, or fluorine, they're not able to participate in hydrogen bonding. This is the only atom able to participate in hydrogen bonding. So again, to draw a molecule that's participating in hydrogen bonding, you need to have the hydrogen bond donor next to the hydrogen bond acceptor. So I'm actually just going to draw that hydrogen bond acceptor close here and then draw in the rest of the molecule. And remember that molecules can tumble and move around one another in solution, so we can draw this molecule however we want, such that the hydrogen bond donor and the hydrogen bond acceptor are proximal to one another. And we can show this intermolecular force, this hydrogen bond, by drawing a dashed interaction like that. For this problem, this is really the only option because, again, methanol, that's what this molecule is, methanol, only has one hydrogen bond or one hydrogen atom that can participate in a hydrogen bond. So this is the only option that we could draw. Let's look at our last example here. In this case, let's do the same thing. Let's draw out this molecule just so we can see all of the atoms that are possible here. So drawing proper Lewis structures is a critical skill for thinking of many aspects of intermolecular forces. Now again, in this case, we can see these two hydrogens are able to participate as hydrogen bond donors. But there are two atoms who could participate and hydrogen bonding by being acceptors, and that's both the oxygen and the nitrogen. So these, again, are both hydrogen bond acceptors. Now, because there's multiple options here, we could actually draw several structures that would be correct to depict hydrogen bonding between two of these molecules. So let's draw one. We're always going to have one of the hydrogens on nitrogen acting as the hydrogen bond donor. So let's draw two cases here. Let's draw one where the hydrogen bond acceptor is going to be a nitrogen in an adjacent molecule, and then we'll draw another one where the hydrogen bond acceptor will be the oxygen. So I'm going to draw these fairly quickly here. So here again, okay. So if we take this one and we draw it so that the oxygen is the hydrogen bond acceptor, I want to make it proximal, to the hydrogen bond donor on an adjacent molecule. So I'm going to do that, and then I'll have to make sure to draw the rest of the molecule. So this is where we have to make sure we see the connectivity. Remember, again, these molecules can tumble and twist in space. They can flip over. So this is the same molecule as we started with here, showing a hydrogen bond between the hydrogen on this guy and the oxygen on this guy. All right, so let's draw one last example, starting with the same molecule here. But this time, let's have the nitrogen act as the hydrogen bond donor. So again, the only hydrogen bond acceptor possibilities that we have are, hydrogen bond donors are the hydrogens attached to this nitrogen. So we'll draw that, and then I'll make sure to finish drawing out the molecule here. Okay, and whether I chose this hydrogen or this hydrogen, those are both correct.